I want to talk for a moment about duplicate keys. A primary key in one table may have duplicate keys in another table. Remember, to be a primary key, you have to be a unique value. And so in at least one of the tables, there can't be duplicates. But it may have duplicate keys in another table. This is a many-to-one relationship. So when both tables have duplicate keys, there's not a primary key. Duplicate keys in both tables is typically an error, and joining tables with duplicate keys produces all possible combinations. So if we look at these illustrations, here up at the top right, we see that the primary key here has duplicate keys, x1 and x4. And so when we look at 1x for y1, that matches up with x1, but then we get another row in which y1 matches up with x4. With 2, we have y2 matched up with x2 and another row matched up with x3. But notice down here what happens when we have duplicates in both of them. So key number 1 is no problem, x1, y1. But key number 2 matches up with y2 and y3. So we get x2, y2, x2, y3. And then key number 2 also has an x3. So we get x3, y2, x3, y3. We get all possible combinations. It's probably what we do not want, which is why I say that duplicate keys in both tables is typically representing an error. Now let's talk about filtering joins. In the joins we've seen so far, what we're interested in doing is putting together variables. But with filtering joins, what we're doing is affecting observations rather than variables. And there's two kinds of filtering joins that we'll look at: a semi-join and an anti-join. A semi-join keeps observations in one table that have a match in the second table. So if you look at our table on the left side down here in the semi-join, in this left table here, there's a match with the right table, and so we keep this in the result. And then number 2, key 2 has a match, so we keep that in the result, but we don't keep 3 in the result because there is no match of 3 over here. So what we're doing is affecting which observations we keep, and that's why it's called a filtering join. It's a filtering join because it filters out what we keep. Let's go ahead and look at an example of that, and then we'll come back and talk about the anti-join. So let's do this with our flight data. Here's a little script, lines 960 through 962, that are going to find the 10 most popular destinations from New York City. Notice what we're doing. We're taking the flights data, and I'm using the reduced set, the flights 2. We're taking the flights 2 data. We're going to count the destinations. We're going to sort those. And then we're going to get the top 10 destinations. Remember, head takes the first ones, and that's why I've sorted. So I've sorted here so that we can get the top destinations right at the top and sort by that. All right, so let's go ahead and do that. And let's take a look. So there's our top 10 destinations out of New York City. O'Hare, in Chicago, Atlanta, Los Angeles, Boston. Okay, now what we can do is we can find all flights to these destinations and use the semi-join to keep the observations that have a match in the top 10 destinations. You see the usefulness of this? We're taking this top 10 destination object, we're putting it here in semi-join, and then we're matching the destinations with flights 2. Okay, notice I'm doing a natural match. I'm not specifying it, but we only pulled out the destinations. So let's go ahead and run this with a semi-join. And you see what we have is we only have destinations that are among the top 10 that still gave us in the year 2013 141,145 flights, but all of those flights are to only 10 destinations that appear in the data. An anti-join drops all observations in one table that have a match in the second table. So it's just the opposite of a semi-join. Here, when we have a match, like you can see key 1 appears in both the left and the right tables, we have a match, so that's dropped. Here we have a match, so that's dropped. And we're left with this one variable in our left data, this one key, and this one observation that doesn't have any existing data over in the right data set. Well, what would that be useful for? Let's take a look. An anti-join keeps rows that don't match. This provides us information that there are many flights that in our data cannot be matched to the planes in the planes data. So this can be useful for seeing what data are missing in our data tables. So here I'm taking flights, I'm anti-joining it with the planes by tail number, and so what I'm going to end up with is all the flights data for which we had a plane that didn't have a tail number in the data set. And so we found out that there were 722 of them. So we have these tail numbers here, but those tail numbers correspond to tail numbers in the planes data set that we don't have that there. And therefore it would suggest to us that we have some data missing from the planes data set because we don't have the information on those planes with that tail number. So anti-join can be very useful for identifying missing data. Let's consider now the steps that we can often use to clean joins. Well, you remember that one thing we did was we identified a primary key by making sure that it uniquely identified an observation in our data. So we verify that these primary keys are unique by doing counts and making sure there's no more than one of each observation with that key in the data. We also have to ascertain that the primary key does not contain any missing data, and if so, that those missing observations will not be able to use with that key. And we can use anti-join to make sure that foreign keys match primary keys in another table. And we just saw an example of that with the flight and the plane data.